Hey guys, we are on chapter 6. This is our second to last chapter of the semester. This is inverse circular function. So what we're going to talk about in this video is stuff that you should be pretty familiar with. What it is unit circle stuff. There's one new thing. What we're going to do is we're going to restrict the domain. So I'm going to have you give me answers in a specific way. So I'll give you a second to copy this stuff down. A little bit of a new vocab situation that we have here is I know you're used to seeing this. This means give me the degree where the y value, for example, is 1/2 on the unit circle. Another way of writing this inverse situation is arc sine. They mean the same exact thing, and as you can see in the notes, we're going to switch back and forth between both. You need to be familiar with what both of them mean, but it's the same thing as asking for the inverse. There's two different ways of asking it, tangent inverse or arctan inverse. Maybe in physics, if you guys have taken that, you've seen this arc thing before. But here's the new part, is that the sine function, we're going to restrict the domain to -pi/2 to pi/2. What that means is we are only going to be looking at the first quadrant and the fourth quadrant for sine. Okay, so when I ask you an inverse question involving sine, you are going to give me the answer if it's positive in quadrant 1, or if it's negative, because the y value is negative, in quadrant 4. I'll talk to you in class about why we do that, but it has to do with the fact that this is the sine wave right here. As you guys know, we graphed these in chapter 4. And what you should remember from algebra 2 is this thing called a one-to-one function. I'm sure you've heard of that before, but maybe you have blocked all of that out of your memory from algebra 2. But the problem is that the sine wave does not pass the horizontal line test. It touches the graph many times because that sine wave bounces between -1 and 1 forever. And so what we're going to do is we're going to restrict the domain to only this piece of the sine function so that we can have an inverse that exists. And so this piece includes both negative values for sine and positive values for sine, which is why they chose this piece. And we're going to restrict it between -pi/2 and pi/2. Okay, so same thing for cosine. It's restricted a little bit differently because there are positive values of cosine here and there are negative values of cosine here. And what we have to restrict here is between 0 and pi so that we can get an idea of the entire curve for cosine. And then tangent, same thing over here. Only thing that I want to draw your attention to here is that these are parentheses and all the other ones are brackets. And remember, that's because tangent has asymptotes at -pi/2 and pi/2. So just make a little bit of a note about that, is that this is kind of the new part for this chapter, is we are restricting domains here. And make sure you have a note here that these are parentheses. Okay, so I can draw the curves also, or the quadrants here for cosine. We are in quadrant 1 and 2. And for tangent, we are in quadrant 1 and quadrant 4. Okay, so those are the two options that I'm going to ask you for when I give you unit circle questions moving forward, okay? So let's just look at a couple of these examples, and I'll go through these quickly because it is unit circle stuff. If you want to get out your unit circle so that you can follow along, that would be fine. But question number 1, notice what I said up here is that this is just unit circle stuff. We already know these answers, but I want you to pay close attention to the restricted domains. And so what I like to do for these problems is go, okay, this is sine, so my answer has to be on -pi/2 or pi/2. So I'm thinking about my unit circle. Where is the sine value positive? This is quadrant 1. It's also positive in quadrant 2, but that is not in our domain here. We're only looking at quadrants 1 and 4 now with these inverse things. So in quadrant 1, the sine is the y value and the y value of 1/2. So remember, that is our 30-degree angle, or I told you to give me your answer in both radians and degrees. That's pi/6. So that's just looking at the unit circle. Where is the y value? Because it's asking about sine, positive 1/2. Okay, so I'm not in quadrant 4 because the y value would be negative there. Let's do a couple more. All right. So this one, the sine of -1. So remember, that's the y value of -1. So thinking to the unit circle, I'm only allowed to go this direction or this direction, and the y value is -1 right there. And so that answer is 270 degrees, but that's not in my domain. I'm going to refer to it as negative 90 degrees because remember, I want you to restrict your answers to only positive pi over 2 and negative pi over 2. Negative pi over 2 is the same thing as negative 90 degrees. So the radian version is negative pi over 2. The degree version is negative 90. It's the same thing as 270, but just be very careful and intentional about how you give me your answers. It should be on this domain here. Okay, let's do a couple more. Inverse sine of negative 2. So where is the y value negative 2? Okay, if you guys remember what the sine curve looks like, doesn't it bounce back and forth between negative 1 and 1? So does it get down to negative 2? It doesn't, so this is not possible. So remember all that stuff that we had you memorize, chapter 1? Remember we had you do negative 1 is in between sine and positive 1? And so that is why we can't have a value less than negative 1 or bigger than 1. Just remember what the graph looks like, and that is what these questions are asking you about. Okay, let's talk about cosine. All right, so cosine, where is the x value equal to 1? So the x value is 1 here, and that answer is 0 or 0 radians. That's the only place where the x value is 1. Okay, let's do another one. All right, in this case, where is the x value negative radical 2 over 2? And so remember for cosine, our options are quadrant 1 or quadrant 2. Remember that's from 0 to pi. That's where we're restricting our cosine answers to. And so this is going to be in quadrant 2 because that's where the x value is negative. Yeah, there's another answer. The x value is also negative in quadrant 3, but that is not, again, go back up here. Quadrant 3 is not in our domain. So we are restricting our domains here. So in this case, in quadrant 2, my degree is 135 degrees, where the x value is negative radical 2 over 2. Or if I wanted it in radians, it would be 3 pi over 4. Okay. Tangent of 1. So remember that tangent, the options are quadrant 1 and quadrant 4. In this case, since we are positive 1 here, we are going to be in quadrant 1. And where is the tangent equal to 1 in quadrant 1? My theta is going to be 45 degrees, or it's going to be pi over 4 if I wanted my answer in radians. Okay, just a little bit of a note. Do you notice anything different about 1 through 5 versus 6 in the way that I asked the question? Just so you know, the directions did say give your answer in both radians and degrees, but how to tell, like if you're doing a Math Excel question, what they want is that y means give your answer in radians. This is technically. And theta means give your answer in degrees. Just as an introduction, that's the difference, and that's why they're written a little bit different here. Just wanted to introduce that to you and give you an idea of what's happening. But that's something that you should be kind of watching out for, is how to give your answer. It depends on how the question is asked. Okay, but the directions here did say give your answer in both, so that's why I'm doing both here. Okay, the last problem I want to do is this one, and then we'll finish in class tomorrow. This one says theta equals secant. Okay, we haven't done anything about secant yet. I can't look up at the top and find anything about inverse secant, so let's change this into inverse cosine. Remember how they're inverses? So that is something I easier recognize. And because the cosine is positive, remember I'm restricted on 0 to pi. And since x is positive, I know this means quadrant 1. So where is the x value 1/2? My theta is 60 degrees. That's just from the unit circle. Or radians, pi over 3. Okay, so that's just an intro. I know you guys had a test today and you're burnt out on math right now. I just wanted to introduce the chapter and show you how similar it is to stuff we've already done. The only new thing that I want you to be concerned about right now are these domain restrictions. So now when I'm asking you a unit circle question, you're not giving me two answers, like two different locations where the x value is something or the y value is something. Because we have a restricted domain and we're only looking at two quadrants, that's where I want you to give me my answer. So that is all for right now, you guys. Have a great night. Thank you for watching. Bring your questions to class. I'll see you tomorrow.